The power topologies used in modern AC to DC and DC to DC converters are switching at frequencies up to several hundred kHz. In addition, the very fast switching processes in the powertrain generate high-frequency spikes on the output voltage. Capacitors smooth out these pulsed voltages. However, a certain amount of switching frequency ripple and high-frequency noise up to several tens of megahertz remain at the output. This video describes how ripple and noise are measured correctly at the output of a 100 watt AC to DC power supply with a resistive load of 60 watt. A typical oscilloscope probe with ground wire forms an antenna that captures radiated interferences from a switched-mode power supply without even being connected to the output. If the ground wire is wrapped around the probe, the captured noise is reduced by a factor of 2.5 in this example. It is therefore important to avoid wire loops and to keep the enclosed area as small as possible. Ripple and noise are measured directly at the output of the converter with a bandwidth of 20 MHz. For the correct measurement of output ripple and noise, we recommend connecting the probe directly to the output of the converter without using a ground wire. If this is not possible, you can also use a shielded BNC cable soldered to the output of the converter. An initial measurement still captures high-frequency spikes generated by the extremely fast switching processes in the converter. Results also vary depending on the equipment used, be it a digital or an analog oscilloscope, but what we can already see are the various frequencies. The cycle time of the switching process in the powertrain is 18.84 microseconds, which means a switching frequency of 53 kHz. The continuous charging and discharging of the capacitor is called ripple. The short spikes are caused by fast switching processes of the semiconductors in the converter. A general recommendation to eliminate very high frequency spikes is a 100 nanofarad ceramic capacitor across the output of the converter. You will notice the significant difference when adding this capacitor to the measurement setup. The high frequency noise is significantly reduced. The results correspond more closely to the real values. In the datasheet you can find the capacitor used for ripple and noise measurements of a specific product. To further reduce ripple and noise on the output, you can add more capacitance. For this measurement we added a 47 microfarad electrolytic capacitor, a typical value used at the input of electronic circuits supplied by the converter. In case of any questions, please contact PDUC's application engineering team.